penuh bervisi guru AYU mencapai misi yang satu, bervisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, Salam Sejahtera and good evening everyone. Welcome to Pusat Tuisyen Akademi Youtuber with the joint venture of eDidik Malaysia and Gulf Malaysia. Bermula percuma, selamanya percuma. I'm Mr. Peh. Currently, I'm teaching at College Tingkatan 6 Tun Fatimah Melaka, and I'm the on-duty teacher for this week. With the end of the subtopic of Form 5, which is 7.3, which was conducted at last Sunday, so we have finally finished our Form 5 syllabus and cover all the subtopic of Form 5 in academic year of 2024. And start from this week, our class Fizik SPM Form 5 DLP group will be start our revision series with all of the candidates of SPM. So I hope that all of the candidates of Fizik SPM 2024 will be stay together with us until you are able to finish your physics paper 1, 2, and 3 in this year. Okay, so without further ado, so here I would like to tell you that the lesson for today will be mainly we are doing the revision on the Form 4 Chapter 1 and Chapter 2, which will be the measurement and force of motion 1. And here we will mainly discuss about the Paper 2 answering technique with the trial paper of 2024 from different state. Okay, so here the link schedule will be also provided to all of you at the end of the lesson. Okay, and then you have to fill out the link with any available email. Okay, so here in the line we have the Jimmy and together with Cikgu Hasnitah. So thank you for joining my lesson. And for today's discussion, you can actually download the worksheet with this link where I already sent into the chat room. Okay, so without further ado, let us start our discussion today. Okay, so basically this is a format instrument of SPM Physics. So here will be classified to 3 papers. I think all of you should be familiar with that already. So I just remind again for those who are still not familiar with the format you are going to see on your actual paper. Okay, so for paper 1 and paper 2, there will be ujian bertulis. Paper 3, there will be ujian amali. So for paper 1, there will be have aneka pilihan and aneka gabungan. So the aneka pilihan, that means there will be the option for A, B, C, D. The gabungan, that means that the option can be A have 1, 2, B have 3, 4, and others. So this type of question will be not more than 3 questions. Okay, so the paper 2, there will be 3 type of questions. Subjective berstruktur, respond terhad, and respond terbuka. So later on we can see together. So what is the item you are going to see in paper 2? Okay, and then for paper 3, definitely will be structured. So where you actually go through the trial paper already recently, I think. Okay, so the numbers of questions for paper 1, there will be about 40 questions. Okay, then for paper 2, there will be have 11 questions. For section A, there will be the compulsory question, compulsory section where you have to answer all the 8 questions together. So total will be 60 marks. Okay, then for section B, there will be have 2 questions. So there is actually optional. So you can choose one of the answer or you can answer 2 of that. The highest mark will be count at the end of total marks. Then the last will be the section C. There will be have only 1 question, which is compulsory to answer. And the total marks will be 20 marks. Okay, so for paper 3, definitely there will be only 1 question you're going to do. Okay, so the total marks for these 3 papers, there will be 155 lah. So for paper 1, there will be 40 marks. Paper 2 will be 100 and paper 3 will be 15 marks. Then the duration for paper 1 will be 1 hour, 50 minutes. Then for the paper 2, there will be 2 hours, 30 minutes, and paper 3, there will be 45 minutes. Okay, so I think all of you suppose will be quite familiar for this mark distribution also for this different paper. Okay, so as mentioned just now, we will going to focus on paper 2 question today. And the paper 2 question today will be focused on chapter 1 and chapter 2 for your Form 4 syllabus. Okay, so here let us look at the marks distribution for paper 2. So as mentioned just now, there will be have 8 questions you are going to see at section A, and all the questions are compulsory to answer. Okay, so the criteria tested for question number 1, there will be knowledge and understanding. So there will be about 4 marks. Then question number 2 will be test you regarding knowledge, understanding, calculation. The total marks for question number 2 will be 5. Then number 3 and number 4, they will be tested the same criteria. The marks distribution for question number 3 will be 6 marks. Question number 4, there will be 9 marks. Okay, then the question number 5, mainly for 5 and 6, they will be have a conception question. So the conception question will be the question given 2 diagrams and ask you to do the comparison. So these are questions actually you can get full marks if you're able to differentiate the diagram. Okay, so later on I will tell you the method how you do for conception. Then the question number 7, there will be knowledge, understanding, calculation. The mainly here will be the decision making question. Okay, so this will be same as section B, number 9 and number 10. Okay, so also consists of the question which is known as decision making. So the question will given you option, maybe it's X, Y, Z. Okay, and then you have to choose the best option based on the criteria asked in the question. So later on, we will see one question of option B. Okay, section B. Okay, section B together. Okay, then the question number 8 will be knowledge, calculation, and modification. So the section C, they will be also have the question asked about the modification. Okay, so total here, there will be 20 marks for section C also. Okay, so for today's lesson, so we'll cover all the subtopic in chapter 2 and chapter 1. Okay, so where 2 questions will be discussed in subtopic of 2.3 and 2.6. And the type of question here will be the question number 1. Then the subtopic of 2.2 and 2.7 will be related to the type of question of question number 4. Okay, there will be one comparison or conception question. Okay, but I select the chapter 1 question here. And then we have the decision making question for section A and section B question where covering the subtopic of 2.1, 2.4, and 2.5. So after the discussion today, I think that you'll be more understand so what you have already learned in these 2 chapters. Okay, so here there will be question number 1, where will be the trial question of 2024 from State of Negeri Sembilan. Okay, so here, as mentioned just now, there will be the type of question number 1. The total marks here will be 4 marks, and subtopic are going to discuss in this question will be free fall motion. Okay. Okay, so here let us go through the question together. So diagram 1.1 shows a bird feather that is dropped from high outside a vacuum chamber. Okay, so here you see this is the diagram 1.1. So the feather is outside the vacuum chamber. Okay, it's in the normal air surrounding us lah. Okay, and then the diagram 1.2 will be show the same bird feather drop from the same height inside a vacuum chamber. So that means here, mainly the surface area actually for both bird feather will be the same. Okay, if you still remember, the factor affecting the falling time here is actually due to the surface area, causes the air resistance become higher in the case of diagram 1.1. Okay, so here you will found that the feather in the vacuum chamber took a shorter time to reach the bottom. So it will be 1.2. The falling time will be taken about 1.3 seconds. Okay, and then for the 1.1, they will be take longer time. Okay. Okay, so here based on the diagram 1, mark on the correct answer in the provided box on the correct answer in the box provided for the gravitational force adding on the bird's feather. Okay, so here, if you look at the option here, the first will be gravitational force on the diagram 1.1 is equal to 1.2. Okay, then another one, there will be gravitational force on diagram 1.1 is smaller. So which is the correct answer? Okay, so you can share together with me your answer in the chat room actually. Okay, so the answer here is very clear that they will be equal, because both of the feather in different situation here is added with G equal to 9.81 meter per second square. Okay, so the next question here, they will be on diagram 1.3, marks and label the direction of the forces acting on the feather during falling outside vacuum chamber. Okay, so that means here we want to label the forces added on the feather outside the vacuum. So that means they will be have adding by another force. Okay, so here the first will be the weight. So weight will be adding downward. Okay, where will be F equal to mg. Okay, so this is actually related to subtopic 2.8 also. Okay, another, there will be the air resistance. Okay, because inside the normal air, where it's not in vacuum condition, so the air resistance will be added in opposite direction. So where will be adding upward. Okay, so the feather in a vacuum arrived earlier than the feather without a vacuum explained. Okay, so if you look at the figure 1.1 and 1.2. So the 1.1 where the feather drop in the air, so take about 1.7 second, which is longer. Okay, it's actually due to the air resistance added with the different direction of weight. Okay, so this may cause the net work moving down becomes smaller. Okay, so the A, which is F equal to ma, so the acceleration, there will be smaller, okay, compared to the feather adding in the vacuum condition. Okay, so here will be 1 mark. Okay, so here you can give, because the feather in vacuum will be no any frictional force or no any air resistance. Okay, another answer as I mentioned to you just now. So because the feather where in the vacuum, they will be only added by weight. So the downward net force will be greater for the feather in vacuum condition. Okay. So as mentioned also, when F equal to ma, so when net force higher, so with the same mass for both feather in diagram 1.1 and 1.2, so the air will be greater. So you can give these three preferred answer here. Okay. Okay, then the next question number 2 will be also the question type of number 1, where will be 4 marks. The subtopic we discuss here will be 2.6. And the trial question here I want to discuss here is from State of Sarawak. Okay. Okay, so diagram 1 shows the result of an experiment to study the Newton's second law of motion. Okay, so here you need to understand what is Newton's second law of motion. Okay, so the law stated that acceleration A of an object is directly proportional to force. So where will be meet this relationship? And direct proportional to F. Okay, and then the second, the acceleration is inversely proportional to its mass. Okay, so where actually you can see this is shown by the graph. A against 1 over m here. Okay. Okay, so the relationship can be expressed as F equal to ma. So this is the formula we are going to use in the Newton's second law of motion. Okay, so the definition, you can rearrange this formula. So where A is actually equivalent to V minus U over T. Okay, so this will be actually the rate change of velocity. Okay, so and this will be the formula for rate change of momentum. Okay, so where the momentum formula will be mv minus mu. Or the change of momentum formula will be mv minus mu. Okay, so the definition, if you follow the textbook definition, so it will be given as Newton's second law of motion state that rate change of momentum, this will be at here. Okay, so rate change of momentum is directly proportional to the force. Force will be this. Okay, and act in the direction of the applied force. Okay, so this is what? Okay, so this is what related to the definition. Okay, so here we answer from Zhan Hao. So Zhan Hao give the answer. The force adding on an object is directly proportional to the rate change of momentum of the object. Yes, you can give that. You just reverse the definition I given here. Okay, so the force adding on an object is directly proportional to the rate change of momentum. Yes, this is correct. Good answer from Zhan Hao. Okay, so I hope that other students also can show your answer in the group so that we can discuss together. Huh? Okay, so thank you for Zhan Hao to show me your answer. Is accepted. Huh? Okay, so here the next. So what is a physical quantity which you need to keep constant? Okay, so here you can use again the formula just now I explained to you, which is F equal to ma. Okay, so from the graph, A against 1 over m. Okay, so the y axis will be A. and the x will be 1 over m. So you can see here, there is another parameter in the formula. Here will be the force. Okay, so here, answer will clear that there will be actually force, and it will be the gradients of the graph. Okay, so we go for another question here. Okay, so state the relationship between the acceleration A and the mass. Okay, so here, from the graph, you can see that the straight line is passing through the origin. So the A is directly proportional to 1 over m. So it means that the A and m is inversely proportional. Okay, so this question is actually, you have learned the graph already at subtopic of 1.2. Okay, subtopic of 1.2. Okay, so you have to give the relationship here with inversely proportional. Okay, so the graph is actually like this, where when A against 1 over m, you will get straight line passing through origin. So this showing that the A is directly proportional to 1 over m. Okay, so the graph of A against m, this will be inversely. Both of the graph actually bring the same relationship between A and m. Okay, then the next question here will be D. So based on the diagram 1, determine the value of reciprocal of mass 1 over m. So the question asks you to find 1 over m. So when the A is equivalent to 10. Okay, so you can just get your answer from the graph. Okay, so here you can show your answer in the graph with the dashed red line, just like what I show you in the diagram here. So you can see here, 10 meter per second square. Extend the line, touch the gradients, then you will get your 1 over m equivalent to 0.41. Or the one small box here represent 0.1. Okay, so the answer is very clear that there will be 0.41. Okay, so I think this question is quite straightforward. Okay, so this is the type of question you're going to see in question number 1. Okay, so now we go for question number 3. So here will be the type of question number 4. Total marks for this question will be 9 marks. And the subtopic we going to discuss here will be the linear motion graph. Okay, and the trial question we use here will be from state of Salam. Okay, so here diagram 2 shows a velocity time graph. Okay, so from this subtopic, actually you have learned 3 different type of graph, where will be the displacement against the time and velocity against the time. Another one, there will be acceleration against the time. Okay, so here, let us look at the graph where v against the time here, there will be velocity against time. Okay, so explain a movement of the object A at AB. So you can just observe okay, so here the tips will be like this now for graph, v against t. So the gradients of the graph represent the acceleration. Okay, represent the acceleration, and then the area under the graph will be the value for displacement travel. Okay, so this is what you must already in your mind for this type of graph. Okay, so here look at the AB. So the AB actually showing you positive gradients. Okay, and just how we mentioned already, the gradients represent the acceleration. Okay, so the motion here you can give as constant acceleration. Okay, constant acceleration, or you can give increasing velocity. Okay, acceleration. Okay, so here you have to give the type of acceleration here. Okay, so here the better answer for acceleration, there will be constant acceleration, or you can give the increasing velocity. This is the advanced answer for AB here. Okay, so then the BD. Okay, so you can see here the BD showing us the negative gradients. Okay, so here you can see we have 2 different parts. So for the parts above positive lah, here. So both is actually given negative gradient. So the negative gradient here is actually tell you that at the graph where above the 0. So where is B and BC here? So the acceleration actually decreases. The velocity actually decreases from 30 until 0, right? So after that, you can see the velocity magnitude is actually increasing from 0 to 30, but is in opposite direction. Okay, so that means that from CD, the car is actually moving, or the object is actually moving. Okay, and moving in increasing velocity, but in opposite direction. Decreasing velocity. Okay, so the decreasing velocity. Okay, so let us discuss together. Judging. Okay, so you can look at the BC. So the BC will be correct if you give decreasing velocity. Judging. However, if you look at the CD, so will be from here to here. So the magnitude is 0 to 30, actually showing us the increasing velocity, but is opposite direction from the original position. Okay, so here the best answer for this question actually is BC given us decreasing velocity, where you can see the magnitude from 30 to 0. The car is stopped at the point C. Okay, however, the magnitude will be increased from 0 to 30, showing that this is increasing velocity, but is in opposite direction. So that's why you can see here we have negative. Okay, so thank you for judging to showing your answer. Okay, so you can also give another answer where the CD is a constant acceleration, but is in opposite direction. This is an answer for question A2 here. Okay, so we go for the next question. So here will be the name the physical quantity represented by the gradients of the graph. Okay, so this one we already recur already. Through the hop tips we discussed already. So the gradient showing us acceleration. I think all of you are able to answer it very well for this question. Okay, so the next question here will be name the physical quantity represented by the area. So we also discussed already. There will be the area under the graph. Will be area under the graph. So here displacement will be the answer. You want Okay, then we go for the next D. So sketch the acceleration against time graph of the car. So we have to using this graph. Okay, so here, just now we also mentioned already the gradients represent the value of acceleration. So here we have to find value of AB, acceleration of AB. Okay, suppose will be given you positive value. Okay, so and here the BD will be given us the negative value of A. Okay, so here you have to find AB. The A will be equivalent to 10. So where we using Y, right? Y here from here to here, 30 minus 10. Then here will be 2 minus 0. You will get 10. Okay, then the BD, they will be from here to here. They will be actually 60 or here. Okay, and then this triangle from here to here, there will be 4, 6 minus 2. Okay, so you get negative 15. Okay, so the mark number 1, label exists X and Y with symbol and unit. Okay, so this will be the first mark. You can see symbol A for acceleration, T for time. Okay, and then unit for A will be meter per second square, time will be second. Okay, then the mark number 2, there will be correct value for respective acceleration for certain duration. Okay, so the first AB, there will be 10. will be at here. AB. And then here, there will be for BD. Okay, so this will be the reference answer for this question. I hope that all of you are able to understand. You may ask the question you might say you have doubt in the chat room. Okay, so the next question here, E. Okay, so what is the total displacement travel? Okay, so just now we also explained already. So the total displacement, you can actually calculate the area under the graph. Okay, so here we have actually 3 areas you have to calculate. So area X will be trapezium. Area Y, there will be triangle. Z also. Okay, so here you have to minus the Z because just how we explained already. So because the moving direction for negative V here is in the opposite direction. So that means the object is moving at right at the beginning. After C, it return back until D. So you can see the displacement will be reduced. So that's why we need to minus the area Z. Okay, so here again we're using trapezium. So this is a mathematics you should know how to solve. So here there will be 10. Here will be 30. Half will be the formula, and then here will be the height. So we get area for X. Then for Y, there will be triangle. Again, here there will be 30. Here will be 2. Okay, then Z, there will be 30. Here will be 2. And half. So after that, you can solve. The question you will get finally will be 40 meter. Okay, please give the answer with correct magnitude value and unit also. Okay. Okay, so then question number 4, there will be the trial question from Terengganu, and the subtopic we discussed for this question will be 2.7 is impulse and impulsive force. Then the type of question here will be the question number 4 for the section A of paper 2. Okay, so let us read the question together first. Okay, so diagram 4.1 shows the mortar and pestle used to pound cooking ingredients. Okay, so state the law of physics that can explain the situation in diagram 4.1. Okay, so here, so firstly, we will moving down our pestle, right? So here, downward force, and then hit the surface of mortar. Okay, so that means here there will be force adding downward, where is can know as an action force. Okay, so when hitting the harder surface, there will be one force or reaction force we know as an impulsive force, react with the opposite direction. Okay, so this is actually the third law of motion. Okay. Okay, then the question number 2. Okay, so name the force involved during impact. Okay, so just now we also explained already. So the upward force we know as an impulsive force. Okay, so the impulsive force is the rate of change of momentum in a correction or impact in shorter period. Okay, so here the formula you learn in 2.6. Okay, so where this is known as a rate change of momentum, right? Okay, it's actually the same formula at 2.7, where we know as an impulsive force. Just the time taken is too short in this situation, and we can know as impulsive force. Okay, so here answer very clear that there will be impulsive force. Okay, the next C, explain how the mortar and pestle can quickly pulverize the cooking ingredients. Okay, so here 2 marks. 2 marks question. You have to give minimum 2 points. Oh. Okay, so here again you have to using this formula to discuss the answer. Okay, so first you have to discuss that the time taken is very short. Okay, and then this causes the impulsive force added is greater. Okay, so firstly, fast, faster movement will reduce the time impact. Then second, this will be produce in large impulsive force. Okay, so this will be the reference for this question. Okay, then we go for the next D. Okay, so here will be the calculation question. So diagram 4.2 shows a car collision test. 1,200 kg car hits the wall with a speed of 50 meters per second. Okay, so here this will be referring to M. Okay, and then this will be referring to U, initial velocity. Okay, with the direction to the left given as negative 15. Okay, and then the car bounced back at the speed of 2.6. So this will be considered V. Okay, so if the time collection given as 115 milliseconds, so what is the impulse? Okay, so here you have to know the different formula used in impulse and impulsive force. Okay, so here the impulse will be Ft actually, where we know as change of momentum. So this will be the formula for you to calculate the impulse in the situation in diagram 4.2. Okay, so here, just I mentioned already, so the M, okay, so the M here is 1,200, 1,200 multiply with 2.6. Okay, then the U here is 1,200 also. Okay, so here we have the answer shared by Jiaying. Okay, 140.8. Okay, so let us see together whether the answer is correct or not. Okay, then here, okay, so here we will get the 112 times 10 power 4. Okay, so let us check together whether the answer is correct or not. Okay, so here I think it's more than that, right? So because here we have the 1,200 times 2.6. I think your answer should be the impulsive force, is it? Okay, so here I think Jiaying, we have to get this answer where I show it here. 2.112 times 10 power 4. Okay, so remember to give the answer with minimum 2 decimal places now with correct unit. Okay, so with correct unit. Why NS? Because Newton is the SI unit for force. Then S will be second unit SI for time. Okay, then here impulsive force. Okay, so no problem. Okay, so anyway, thank you for trying lah. So that's why we need to do division here, Jiaying. Thank you for your sharing answer here in chat room. Okay, so we do together in the. Okay, so that's why I want to remind all of you. So the formula for impulse and impulsive force is different. Okay. Okay, so here the impulsive force applied to the car, they will be using this formula. Okay, so after we convert, okay, we had to convert 150 millisecond to second, because here we use final answer in SI unit. So make sure you get to change the 150 millisecond to second. So you see here 3 marks. The first mark will be given for conversion. Okay, then the second you can get from you can get from D1 now. This will be the value we calculated, and you just substitute in the formula, in this formula. Okay, so we will be using 2.112 times 10 power 4 divide 0.15. Okay, so with this. Okay, so here answer from Jiaying. Okay, so Jiaying, I think you forget to change the 150 millisecond to second already. Yeah? So make sure you change your time in second so that you can get your answer. 1.408 times 10 power 5 Newton. Okay, so you can remain your answer not in standard form. There will be 1, 2, 3, 4, 5 Newton is also accepted. Okay, I say anyone? Okay, so here we go for our next question. So I hope that you all able to differentiate the formula between impulse and impulsive force. Okay, so two of that is actually a different thing. Okay, so here we go for the question number 5. Okay, so question number 5 here, again, we take the question from the state of Sarawak. Okay, and then the question tested here is from subtopic of 1.1. Okay, physical quantities. And the tested question here is the type of question of conception from question number 5 or 6 now. Okay, so here will be the question. So let us read the question together first. So diagram 1.1 and 1.2 shows the time for 10 complete oscillation for different length of the length pendulum. Okay, so here we have two different length. One will be diagram 1.1 will be 20 cm. Okay, then 1.2 there will be 50. All be 50. Okay, so I enlarge the figure to you. So you see 1.1 here there will be 20. Okay, so the 20 cm time second here is about 9 seconds for 10 complete oscillation. Okay, then for figure 1.2, the length there will be 50.0. And the time taken here is about 11 seconds. So it's longer. Okay, so let us go through the question A. Okay, so the time is, okay, so here asking you to choose the base quantity or direct quantity, 1 mark only. Okay, so here let us review again. So what is the base quantity? Okay, so the base quantity is a quantity that cannot be derived in the terms of other base quantity. So this is the simplest form already. So we have 7 examples where you can get from a textbook actually. So length, mass, time, temperature, electric current, luminous intensity. Okay, then for the direct quantity, there will be the physical quantity that can be derived from combination of base quantity in multiplication, division, or both operations. So example, we have area. So will be come from length times length, or density is also another physical quantity which is considered as a derived, where come from mass over volume, right? Okay, so here the answer very clear that there will be base quantity. I think it should be not very hard for this question. Okay, then here, observe diagram 1.1 and 1.2. Okay, so here we have 2 diagrams. Okay, so the length of the pendulum. So just how we also explained already. So here the length of pendulum should be the manipulated variable here. Okay, so here you compare the diagram. You just look at the diagram. So you can see 1.1 and 1.2. So 1.1 is 20. 1.2 is 50. Okay, so the answer is very clear that it will be 1.1 is smaller than or shorter than. Here should be using shorter than 1.2. Or you just observe the length. So you can give the simple answer like this. Diagram 1.1 smaller than 1.2. Or you can using mathematics symbol for this type of question. Okay, then period of oscillation. Okay, so here you have to observe the time for both diagrams. So here, period of oscillation will be response variable. Okay, response variable for this experiment. Okay, so here, just now we go through already the picture. Okay, so where you can see here, diagram 9.1, 1.1 there will be 9 seconds. Okay, then diagram 1.2, the time taken here will be 11 seconds. Okay, so here we are very clear that the diagram 1.1 is smaller than 1.2, right? You can using mathematics symbol. So for time, you can give shorter also lah. If I say you really want to give the terms. Okay, then the mass. So mass is actually, mass or pendulum bulk is actually the constant variable. Okay, it's a constant variable for this experiment. So definitely both will be equal. 1.1 equal to 1.2. Okay, so based on the answer in 1B, give the relationship between the length of pendulum and period. So you can see here, if we look at the diagram 1.1, when the length is shorter, time taken also shorter, right? So the answer here will be the length of pendulum increases, the period oscillation increases. I think this is quite straightforward. Okay, then the next here, based on the reading of stopwatch in diagram 1.1, so calculate period of one complete oscillation. Okay, so just now we also know already. So here the time taken will be given for 10 oscillation. Okay, and then the diagram 1.1 time taken here will be 9 seconds. So here's the answer, 9 seconds divide 10. So we get 0.9 seconds. So remember to give the unit for your answer. Okay, then the next, hence to calculate the value of the gravitational acceleration. So the question asks you to find G by using the formula below when L is the length of the pendulum. Okay, it's the length of pendulum. Okay, so here we have to rearrange G with T2. Okay, so here from D1, we know already the T will be 0.9. G is a fixed value where you can get from the formula this 9.81. Okay, so again here we ask about diagram 1.1 where the L here will be 20.0 cm. Again, remember change your length unit cm to meter. Okay, because the G value here will be 9 meter per second square. Okay, so the reference for us will be 9.81, right? So the answer should be closer to that. So you just substitute all the value. Then you can get your answer, 9.75 meter per second square. So again, remind you that minimum decimal places here should be 2 and give correct unit. Okay, so we left another 2 questions. Question number 6 and number 7. Okay, so before we continue our discussion, we may take 5 first, then we can come back again for the discussion. Okay, so please stay with me again. Okay, so see you. Okay, so welcome back everyone. Okay, so let us continue our question number 6. So the question number 6 will be the question from Kedah. Okay, and then here the type of question we are going to discuss here will be question number 7. So where will be the decision making question? Okay, so the subtopic we going to discuss here is related to subtopic 2.1 linear motion and 2.4 inertia. Okay, so here the first question. Okay, so diagram 0.1 shows the national speed limit for heavy vehicles. So here this will be 90 km per hour. Okay, so what is the meanings of the speed? Okay, so here you can actually define your answer through the formula. So the formula will be S over T. So the S here will be the displacement, but here you see speed. That means S here referring to distance. Okay, then T will be the rate. Okay, so answer, there will be rate change of distance. If you give rate change of displacement, they will be wrong because here the speed and the velocity is different. So the speed is a scalar quantity, while the velocity, they will be vector quantity. Okay. Okay, then the next here number. Okay, so the B. So a tanker accelerate from rest until it reach a velocity 80 km per hour in 15 seconds. Okay, so the rest here showing that the initial velocity is equal to 0. Well, this you should also able to identify this. So calculate the displacement of the tanker. Okay, so here give you U, give you V, give you T. They ask you to find the displacement. Okay, so here all the value given already. Okay, so first you have to change your V to SI unit. So 80 km, km change to meter times 1000. 1 hour change to second, you have to times 3600. Okay, so you'll get your V in meter per second. So this will be first mark. This will be first mark. Then second, you have to choose the suitable equation to get your S. So we have value U, V, and T. You can choose the equation number 2. This is a linear motion equation. Okay, so the formula will be given in the formula list. So this one you don't need to memorize. Okay, so we select equation 2. Okay, we substitute 1 over 2. U will be 0. V, we're using SI unit times T. So finally we'll get 166.67 meter. Okay. Okay. So all of you can just show me your answer if I say you're able to calculate your answer in chat room. Okay, then C. Okay, so here diagram 0.2 shows the specification of 4 tanker RS, T, and U used to deliver flammable fuels. Okay, so here, as I mentioned just now, for decision making question, they will be give you few options and then ask you to select the best option here. So here will be the best tanker. Okay, so the numbers of tank. So we have one longer one. This one and long. So that means less, longer option. And then here, the numbers will be more. 1, 2, 3, 4, 5. And then here you can see the tanker is shorter. Okay, so which one you should choose? So you actually need to choose the more numbers one. Okay, so this is related to inertia. Okay, so many tanks. So from here, you can know R and T already. Your option here can be S and U or D because both of these showing many tanks. So reduce the effect inertia or reduce the mass, lower mass. Okay, then distance between the tanks and the head. Okay, just now for R and T is already wrong. So you can look at S and T. So you can see, ask about this distance between the head and the tanker distance. So this one you see showing shorter. Or case U is shorter, so S is longer, right? Okay, so here we need to choose the bigger distance or more far between the tank and head. Okay, so reason, increase time impact so that when the tanker move forward, there will take more longer time to hit the head or the head of the tanker. Okay, so here when time impact increase, impulsive force will be decreased now. Okay, so the force applied at the head of tanker will be smaller. Okay, then here we are sure that option U is also out already. We left S. So the question last will be based on the answer in 7C. Set a suitable tanker. Oh, so here the tanker will be the S. Okay, so now we go to our last question. So the question here is the example question for section B. So there will be long question or 20 marks question. Okay, so the subtopic we discuss here will be 2.1 and actually 2.5 momentum and together with 2.1 actually. Okay, so here is the question from State of Malacca. Okay, so diagram 10.1 shows the spaceship launch using a rocket from a launch site. Okay, so what is the principle of physics applied to the rocket? Okay, so 1 marks. Okay, so here you can see the exhaust gas move downward. Here will be create downward momentum actually, MV. Then at the same time, the rocket will be moving outward. So here you can see the same magnitude but opposite direction of momentum is created now. Okay, so this rule is known as the conservation of the momentum. Okay, you can see here the total momentum conserved in explosion. So the momentum before is actually 0 because the rocket is not moving. So after momentum, there will be m1v1 plus m2v2 So end out you get this formula. This is a formula for calculation involved in the case of explosion. Okay, so here we are clear that the principle here will be conservation of momentum. Okay, another answer is also accepted here, which will be, you can see the hot tips here will be Newton's third law of motion state that every action there is an equal opposite reaction. So the action, there will be actually the exhaust gas moving downward. Then there will be have another reaction, force having an opposite direction. So where will be here? So that means the answer, if you give Newton's third law of motion, is also accepted. Okay, then we go for the B question. Okay, so the B question, there will be normally theory question. So 4 marks, that means you need to give minimum 4 points. But I advise you to give more than 4 points now, because we're not sure that the point given here will be in the scheme or not. So better you can give maybe up to 6 points. Okay, so here explain how the expulsion of hot gases through rocket exhaust can accelerate the rocket outward. Okay, so as mentioned just now, firstly you have to discuss the exhaust gas move downward, right? So how can the exhaust gas produce? This must involve the fuels. Okay, so here just now I advised already, you have to give more than 4 points now. So the first, the oxygen liquid and hydrogen liquid fuel are burned in the combustion chamber so that they will be produced the exhaust gas. So the exhaust gas is ejected out from the rocket at high speed. So you see here involved V1 V1 here. Okay, then the expulsion of hot gases create a downward force. Will be showing at the red arrow here. Then the momentum of the hot gases expel downward. Okay, so here will be the statement related to principle of conservation of momentum. Okay, so here hot gases expel downward is equal to momentum of rocket moving outward, but it's in opposite direction. This will be this, showing by the blue arrow. Okay, so produce large momentum backward. A rocket gain a large momentum forward. The lift force produced is greater than the weight. Okay, so here the lift force moving up, weight moving down. So when lift force greater than weight, okay, so here they will be able to let the rocket move outward, or here accelerate outward. Okay, so the reaction force pushes the rocket upward, causing the rocket to accelerate upward. Okay, so you can see here we have 8 reference scheme answer here. The maximum here will be 4 marks also. Okay. Okay, so we go for the next question. So we go for question C. So this will be 5 marks calculation question related to subtopic of 2.1. Okay, so diagram 10.2 shows a high speed train with this. The train moves rapidly while floating above the track. Okay, so the high speed train changes its speed from 0. So that means U will be 0, and then to the V, where will be km per hour in 10 seconds. This will be T. Okay, so the first question asks you to change the final speed, which is the 360 km per hour in SI unit. So have to change to meter per second. Okay, so here 360 km change to meter times 1000. 1 hour change to second, there will be times 3600. Okay, so here you will get answer 100 meter per second. Okay, then the next will be acceleration of the train in the unit of meter per second square. 2 marks. So 2 marks need to show the calculation for the substitution and answer, so that you can get 2 marks. Okay, so A will be the question asked about. So we know already U, V, and D. So that means we can get A through the formula V minus U over T, or initial final velocity minus initial divide time taken. So here 100 will be the V, U will be 0, T will be 10. You substitute, you get 10 meter per second square. Okay, so this will be the answer for number 2. Then number 3, the distance traveled by the train in 10 seconds. So here ask about S. Okay, so again, we have to choose a suitable formula. So here the question given us U, V already, U, V, and T. So that means you can choose equation 2. Or you substitute U equal to 0, V equal to 100, time taken 10, so you get 500 meter, or 500 meter. But actually, you can also choose the question as the equation 3, so because we get already A from answer C2, 10, T given as 10, U given as 0. So you substitute in this formula, you can get also 500 meter. Or actually, if I say you want to choose equation 4, you can get the same answer also. Okay, so here will be the reference question for subtopic 2.1. Okay, so we go for the last question, 10 marks question. So here will be, again, is a decision making question. You have to choose a suitable option here. Okay, so assume you are an engineer assigned to create a model of high-speed train in Malaysia. Okay, so referring to table 10, you are required to investigate the picture of the high-speed train. So that means we need to have the train moving in higher speed now. Okay, so here the option, side view of shape of the high speed, we have two options, pentagon and aerodynamic. Okay, and then we have the material to build the body, low density or high density. Then numbers of coaches, okay, coaches of the high speed train. We have the long and one. Another one is 8 short coaches. So you have to choose longer or less number. Or another one will be more coaches but is shorter. Then another option here, you have to choose the material to make the electromagnet. Okay, so here we have superconductor or iron core. Okay, so here the question asks you to explain the suitability for each characteristic of high-speed train. Determine the most suitable high-speed train which can move with higher speed. Also, the highlight here, they will be higher speed. Okay, so give a reason. Okay, so again, you have to do in table form. Okay, so here, the first will be the shape. We have two options, pentagon and aerodynamic. Okay, so definitely, we need to choose aerodynamic because the aerodynamic here can reduce the air resistance. Okay, we can reduce the air resistance. So here we have to choose aerodynamic. Okay, so here please do not mix up with aerofoil. So the aerofoil will be applied at the flight, the wing of the plane. Okay, the purpose is to produce the lift force. Okay, this is different between the aerofoil and the aerodynamic. Okay, so the aerodynamic will be the body have the stream body to decrease the air resistance or water resistance. If I say we apply in the ship, okay? Okay, so here we have to choose aerodynamic. Reason, reduce the air resistance so the speed can increase now. So you can give these two reasons. Okay, and then the material, since we need to have a higher speed, that means the density we choose must be low so that it will be lighter, can easily accelerate. Okay, so here you can see for the first option, when we choose aerodynamic already, so that means the option P and S out already. Later on, we just look at the option for Q and R only. Okay, then just how we explained already, so the material used should be low density. Okay, should be low density. So that means, again, we are very clear that the Q will be also out already. So we choose low density because it is lighter, or you can give increase the speed or easily accelerate. Okay. Then the next here, okay, so Q also already. So we are very clear that the direction should be go to R only. So here we will be choose 8 short coaches. So that means we have to choose more numbers of coaches and shorter. Okay. Okay, so the coaches will be C. This is coaches 1, coaches 2, coaches 3. So this is the room now. So we need to have more. Just like the example we explained in the tanker. So here is related to inertia actually. Okay, so here we have to choose more and short coaches. Okay, this is related to inertia. Okay, so we have to reduce the inertial impact if the train stops suddenly. Okay, then the next will be the material for electromagnet. So here we have to choose superconductor. So this will be related to subtopic I think it's Form 5 topic or chapter 4. Okay, so here we have to choose superconductor. Okay, because superconductor can reduce the friction because can cause the train float and not touching the track. Okay, so it will be reduce the friction, so that allowing the train moving at higher speed. So we are very clear that the option here will be R, because it is aerodynamic design will be this. Lighter weight material. Numbers of coaches here will be more and shorter, and then the material used here for electromagnet will be conductor. Okay. Okay, so I think this will be the all sharing about the revision for first series regarding the chapter 1 and chapter 2 of Form 5 topic lah, huh? Okay, so before we end the lesson, I would like to share to you the link e-schedule for lesson today. Okay, so please fill up. Okay, you may fill up the link within 30 minutes. Okay, just finish the live today. Okay, and you can use any email to fill up the link e-schedule. Okay, so the link already sent to the chat room. Okay, will be this. Okay, so please click like and share link for lesson today for your friends, so that more of your friends able to get benefits from my sharing today. Okay, so don't forget to follow the next physics classes, where every Friday they will be for the Form 4 Physics PM, 9:30 p.m. So another class will be Sunday, 8:45 p.m. So the next session will be conducted by Cikgu Hasnitah, and the revision series number 2 should be discussed with you. The topic of Form 4 again, but it's for chapter 3 and 4. Okay, so thank you for everyone who learn together with me until now. Okay, so see you again next session. Okay, so bye bye everyone.